Okay. So, if we had time, I would love to go over this stuff in detail again and show you hopefully what makes intuitive why subtracting 6 does what it does, why multiplying by 2 does what it does, why adding 1 does what it does. But now, I just kind of have to assume that you got a fairly good notion of it, and hopefully you chose the route that includes learning and not just memorizing. So, let's talk about this guy right here. What is outside of the absolute value when you subtract 6? Well, it makes all the outputs, whatever this puts out, it makes them 6 less than that, right? And so it takes those outputs and makes them 6 less. And on the graph, that's a vertical thing, right? If we take the outputs, y values, and make them 6 less, that's a straight movement down the 6, right? So it shifts it down 6. What about this guy right here? What does it do when you multiply the outputs by 2? Up 2. Gavin going like this. What's that, Gavin?
Changes the angle of the
Okay.
graph.
So it's like slope.
It's exactly like slope. It is exactly like slope. In fact, we could say it makes the slope 2 times greater. It makes the steepness 2 times greater, or 2 times as great. Okay, so 2 times as steep, twice as steep. And here's the weird one. Adding 1. What is adding 1 inside the absolute value? Adding 1 to x. What does that do?
Moves it to the left, or
Moves it left. Yeah, moves it left 1.
so if it's subtracting it to the right,
That's right. If you were to subtract 1, you would move to the right.
why is it opposite?
Why is it opposite? Okay, so let's talk about that real quick. Y equals the absolute value of x looks like this. Well, if we were to add 6, then it would take, the output is the vertical, right? So we go over here, and the output is how we get to, we go up or down to the output to get to that point. So if we add 6 after we do the output of absolute value of x, then we could look at it like we would go to absolute value of x, but then we go up 6 from there, right? Up 6 from there. So all of these points, you would go up 6 from those, and it would shift it up 6. So that kind of makes sense. We're changing the outputs. We're making them 6 greater. Outputs are vertical because this y is vertical, and so it moves it up 6. But why, when we subtract 1 or add 1, why does it do the opposite of what we might think it would do? I'm going to move this over. Why? Why all this? Okay. Now, separately, we'll do y equals the absolute value of x. Let's say plus 2. Make it more severe. Something that's helpful is to think about that thing right there. That point on the graph. That's what we call the vertex. Okay. Right now the vertex is at the origin. Okay. And you'll find the vertex wherever the inside of this is 0. Because at 0, there is an output, but the output is nothing, 0. And then as you move to the right, now you start to also move up, and you move to the right some more, you move up some more, and you start to go up this side of the graph. And if you go to the left of the vertex, you go over and you go up some, and over and up some, and over and up some. Right? So this vertex is like this, it's like this nice, central, helpful way of looking at the graph. And it has symmetry about the vertex, and it has all sorts of good things about it. Okay. But the key thing about the vertex is you'll find the vertex when the inside, right, this stuff inside the absolute value is equal to 0. So when the insides, in the guts of absolute value is 0, that's where that x value that you plug in to get that to be 0, that's where you're going to find your vertex. And then just to the right of that, right, if you move 1 to the right of the vertex, the inside of the absolute value will be 1. If you move 2 to the right, the inside of the absolute value will be 2, and so on. And then you'll see that shape start to take place around the vertex. So if we add 2, then to get the inside of this to be 0, what number do we have to plug in for x?
-2.
Got to plug in -2. Right? If we go over to -2, the point right there, we put in -2, that's the new starting point, the new place where the vertex has to be. Where the inside of that is 0. Okay. So the effect that adding 2 has is it makes all these x values 2 bigger. Right? So now 0, when you put 0 in for x, it acts like 2 used to in this one. And 1 acts like, or -1 acts like 1 used to over here, because you take -1 and add 2, you get +1. And -2, when you plug it in here, making it 2 greater, -2 kind of acts like 0. Does that make sense? Does that help at all, Kayla?
Yeah.
Okay, so the effect that adding 2 has is that it makes everything 2 greater. And so everything that you put in for x in order to kind of find the absolute value like we're used to seeing that graph, everything has to, the actual x values have to be 2 less to compensate. So it moves over to the left 2 in comparison to the absolute value of x. All right, so it's going to move to the left 1 and down 6, and it's going to be 2 times steeper. So the left 1, down 1, 2, 3, 4, 5, 6. Okay, you can put a point right there. What do we call that point? Yeah, vertex. Right, or just put where the vertex is. If I move to the left 1 and down 6, I just took what was at 0, 0 and moved it over here and down there. So the vertex is moved over 1 and down 6. And it's 2 times steeper. The original absolute value of x is a steepness on the right side, a steepness of a slope of 1. Right? It has a slope of 1 on the right side. So this will have a slope of 2. It'll be twice as steep. So I don't know if I got to say this in the last class. This number out in front that's multiplied by the absolute value is the slope. Well, it can't be the slope of the whole thing, right? Because these two things have 2 different slopes. In fact, they have opposite slopes. Not opposite reciprocals, but opposites. This could be the slope of the right side. So we could do the slope of the right side and then draw a mirror image of that on the left side. Right. So shifting up and down, shifting left and right, making steeper or less steep. So if we know all that stuff, we look at this graph, and we compare it to the absolute value of x graph, is it shifted up at all? Or down? Up or down? Vertically? Left or right? No, it's still right there. So we're not going to do anything like this or like this. What is different about this one? The slope. Yeah, the slope is different. Right? How, well, here's the absolute value of x. It would be like this. On the left it has a -1 slope, and over here has a +1 slope. So how steep is this graph compared to this graph? It's less steep. It's how much the steepness of the original graph. What? A third is steep. This one goes up 3 and over 3. This one only goes up 1 and over 3. So it's a third the steepness of the absolute value of x. So we multiply the outputs of the absolute value of x by 1/3. 1/3 of 1 will be 1/3. 1/3 of 2 will be 2/3. 1/3 of 3 will be 1. See how all the outputs are multiplied by 1/3. They're 1/3 of what they were. Questions? Let's say that I was attempting to graph this absolute value, or not this absolute value, this piecewise function. And I just walked up and said, all right, 2x plus 1, y-intercept of 1, and a slope of 2, so I go up 2 and over 1, and I just graph it. Is that what I was supposed to do? And then just like maybe graph this one right on top of that. What have I done incorrectly?
You didn't put the vertex.
What's that?
You didn't put down the vertex.
Didn't put down the vertex?
Guess that,
Well, not all the graphs are going to have a vertex. This one does. It has a nice little pointy thing. But if I were to graph y equals 2x plus 1, it would just be a line with a y-intercept of 1 and the slope of 2.
Well, if x is greater than or equal to 0, so you have to stop the line at 0.
Stop it at 0?
Yeah.
So like don't use this part of it?
Well, I mean, no, yeah. Other side.
Other side.
If
Use this side.
If the x, if it goes into the negative x coordinates.
Yeah.
then you just don't show that.
Good. Yeah, yeah. See, this function is only usable if x is greater than or equal to 0. If it's not that, if it's negative, we don't show that. We don't show that at those x values. Very well put. So we do not show this graph for negative x values. But for 0 and for anything that's positive, that's what this says. 0 is okay. Anything bigger than 0 is good. We use that graph. So that's the red one. We'll do this one in blue. Where are we going to use that graph? That function. Kevin?
For all the negative x coordinates that are less than 0.
Yep. So for all of these values this way, all of these values of x that are less than 0, we'll use that function, negative x plus 1. Take those away. Put that back. So y-intercept of 1, that happens to land right on top of this other guy. It also has a y-intercept of 1. That's nice. I'm actually going to be real technical here. I'm going to put an open circle for the blue one. Why did I put an open circle there?
Because it doesn't include 0.
Doesn't include 0. It's just only for values of x that are less than 0. Now, if I had a pencil and it was only one color, well, then it would just look like a filled-in circle, and that would be just fine. But if they don't match up, then it's important to have one closed and one open. Okay, so then this one has a slope of -1, so we go down 1 to the left 1, right there. Oh, it's a negative slope. So we'll go up 1 to the left 1. There. There we go. Are there any questions about that? About piecewise functions at all? Any homework questions about piecewise functions? Anything else? Anything about absolute value? Okay, then we'll just pass it in. It's all good. You're all experts then, I suppose. Graphing inequalities again. We've graphed inequalities before. And just to review, that's what we're going to do. We're going to graph some inequalities. Some one-dimensional inequalities. X is greater than or equal to 3, and x is less than 5. So I want you to graph those two inequalities. See if you remember how that goes. Okay, so a graph, which is what we want to make of these. A graph is a visual representation of information of some kind. That's what a graph is for. That's why you hear things like, typography, right? What's another one? You know what a lithograph is?
Sounds familiar.
What's a lithograph? You just nodded your head.
I remember hearing that.
Rings a bell.
Okay.
I know the word.
Oh, isn't it like bar graph where they touch?
A bar graph for the touch?
That's something.
A histogram?
Yeah, it's close enough.
Okay. So a lithograph, unless I'm remembering it wrong, but I'm pretty sure I'm not. It's just like a reprinting of a piece of art, right? But the graph part is like the picture or geography. What's geo? Earth and graph. Picture. Okay? A picture. A picture of the earth. Geography. So that graph word has to do with pictures, visuals. So we're going to draw a graph. It's going to be a picture of this information. The information that x is allowed to be greater than or equal to 3. So the picture we typically use is this straight line in 2 dimensions, or 1 dimension, really. 1 dimension. This one, left and right, horizontal dimension. So here's, we like 0 as a reference point, and there's 3. Okay, so if we wanted to show that x was equal to 3, what would we put here? Just put a point right there. Right there. X is equal to 3. Is that okay? Can x be equal to 3? Yes, x is equal to or greater than 3. How do I convey to you in this graph, in this picture, that x can be greater than 3?
Shade to the right.
Just shade it, right? Make it real obvious that all these points are included. All this shading is just, if I don't shade it, right? Here's a point where x is bigger than 3, right? Is that correct? And here x is bigger than 3, and here, everywhere in between, and everywhere to the right of these points, and everywhere to the left and up to 3, and right? If we were to put all the points we could possibly put, we'd wind up filling in that shaded area. That's what those shaded regions represent. It's just like all the points being represented. 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Okay. So can x be equal to 5? So how do we show that x can't be exactly 5? Open circle. And then how do we show that x can be anything less than 5? Shade to the left. All of these points right here are okay. X is okay. It's okay for x to be those points. Okay. Let's change what the variable is and see if that changes anything. Y is greater than or equal to -2, and y is less than 9. Okay, just trying to show something about one variable. I'm trying to show you information about one thing, therefore one dimension is the most that you need to do. You could do other things, but that's all you need to do. It doesn't really matter that I'm calling it y. I can call it y, I can call it x. 0, I'll put a -2 right there, and -1. And it's okay that it's equal to 2. And we'll shade greater than 2. And then if it's less than 9, here's 9. And we'll call this 0. Why not? Can't be equal to 9, but less than 9 is okay. Okay, no big surprise. Hi.
Can I borrow Daniel and Jake for just a minute?
Jake and who else? Oh,
Daniel?
Yeah.
Just
Well, and I saw most of you drawing it horizontally, which is great. I mean, it doesn't matter if we call it x or we call it y. We'll just say the variable is called y. It can be less than 9. The variable is called y. It can be greater than or equal to 2 or negative 2. But if we think about what y means in the graphs that we typically will do, which is in 2 dimensions, what's the difference between that y and the way we're showing this y? Yeah, that y is vertical. So we could take this, move it over here, rotate it like that, and now,
I honestly almost started doing that at first.
yeah, that would have been fine.
Just based on
Now, there's no rule that says y has to go up, right? But it certainly is helpful if we're going to do 2 dimensions. If we make x go this way and y go vertically, that works. You could make x go horizontally and y could come out of the page, right? That would be a second dimension. It would be a little hard to do on your paper though. You just like build. You have to get leads and just glue them to paper. That would be very hard. So we'll make it horizontal and vertical. That's helpful. So just a little preview of what's going to be going on here. So before we go into 2 dimensions and inequalities at the same time, we'll just go into 2 dimensions and equals. So we'll have an equation where there's just equality. We don't even have to worry about greater than or less than. We'll use this equation. Y, pen goes right in as well. Y is equal to negative 2x minus 1. Right? So graph that, show that relationship between x and y. So what I'm about to say is just going to be really reiterating stuff I've already said about graphs, but I can't say it enough because I can't overemphasize the importance to understand this. So if we let y be vertical and we wanted to say that y was equal to negative 2, then we could go to 0 and down from there 2 and put a dot right there. Right? So let's say we were to try and do that. We just drew this number line. We just drew it up and down instead of left to right. We called that 0. Then, where should I put the dot for y? Should I put it up here or down there?
Down.
Down? No, down to where?
-1.
-1? Why -1?
Because -2 is being multiplied by x, so you can't do anything with that.
Oh, wait, so what?
Why?
I mean, now you're bringing x into it.
Yeah, because it's
Is
part of
x
the,
important?
yes, because it's part of the equation.
Yeah, and it really, I've not said that this is the y-axis. I'm just saying that this represents what the value of y is. Right? So what is y worth?
We don't know.
We don't know. We don't know until what?
We know what x is.
Until we know what x is. Okay. So y can be lots of things.
Mm-hmm.
Right, it could be a lot of different things. It could be lots of things, and what it is dependent on
On the value of x.
the value of x. Okay. So y is what we call the dependent value. It depends on x. It can't have any value unless x has a value. So x is what we call the independent variable. Right? It has all the control. It has to have value before the dependent variable can have value. So perpendicular to this y number line, we'll put an x number line. And Both of them will have the same kind of markings.
There's a graph.
What's that, Michael?
Name's
Or-
Tyler.
What?
Name's Tyler.
Mitchell. Tyler Mitchell.
Mitchell.
What? You have two
Mitchell.
first names.
Mitchell.
Tyler Mitchell. What were you saying?
I was just saying it looks like a graph.
It looks like a graph. Yeah, exactly. It looks like a graph. It looks like a graph. I'm sorry.
All this over there.
I was trying to draw while I remembered your name. And it's still a little
Yeah,
early to know
Mitchell.
everybody's name. It's a good thing I don't know your name. If I knew your name, it means probably you're a troublemaker at this point. If I know you early on, then you caused me enough grief that I remember your name. Anyway, so that's exactly what it is. It is a graph. It's a two-dimensional graph. We could have three-dimensional graphs, four-dimensional graphs. That'd be kind of hard to picture. But we could definitely do two, and we could do a third, but we won't do a third yet. We'll just keep it at 2 dimensions. Okay, so what should y be equal to? Well, that depends on x. Okay, and now we can show that relationship. If x is this, then y is this. If x is 0, then y is -1. That's what we call the y-intercept. And if x is 1, then y is what? If x is 1, then y is -3. If x is 1, then y is -3. Okay, and now we see the beginnings of what we call the slope. We go over 1 and down 2 for every new point. And we can draw our line. Okay. So all I've done really is say in a slightly different way that this graph is a representation of the relationship between x and y. If x is this, then y is this. That's what the line is. The line is just a bunch of points that are drawn so closely together that now they form a line. Okay. So let me ask you this in this way. If I pick a point from on the line, okay, that's a special point. Like this point's not very interesting to us, right? When we consider this statement right here, okay, it's the points on the line that are special. Why are they so special? What's special about them?
Yeah.
In what way are they? Do you say they are? What about the points? Not like a dot, right? Not a dot on a paper. That can't be a solution. What about it is the solution to the equation?
That if you put the numbers in the x and y, you'll get that point.
Right. Each point, depending on where it is, represents two values: an x value and a y value. And if you plug that x from this point and the y from this point into these variables, then you'll have, well, this will be true. This equal sign will be saying the right thing. It'll be saying this side is equal to that side. Okay? You're not getting that? It's important. I'm going to keep saying that over and over and over. So you should really hang on to that. If I take a point from here and I put the x value in there and the y value in there, then both sides will be what?
Equal.
Equal. They'll be the same. They'll be exactly the same. Okay. Let's say, for instance, 1, 2, 3, 4. Let's say this is -5. Okay, that point on the line has an x of -5. What y value will it have? It'll have a 9 as a y value. Okay. So we put a -5 in for that x and a 9 in for that y, then both sides will be the same. They'll be equal. And that's what is special about the points on the line. Okay. Well, what about this point? Let's say it's -5, and it looks like maybe 8. -5, 8. Okay. If I plug that x and that y in, will we have a true equation?
No.
No, it won't be true. Well, if both sides aren't equal in an equation, then one side has to be what?
Big.
Has to be bigger. Or
Small.
if one side's bigger, the other side's smaller, right? So one side has to be bigger, or just as true, one side has to be smaller. Okay. If we were to plug in this y and this x into this thing, then which side would be smaller? The side with the x or the side with the y on it? Which
Yeah.
side would be smaller?
Yeah.
The x side would be smaller?
This-
Let's see.
Wait, no. The y side.
Why do you say that?
Because if you take, if you put it on the y side, it's gonna be a bigger negative than the y side.
What I'm talking about putting 8 in for y and
Oh.
negative 5 in for x.
Yeah,
Then this side will be smaller?
should,
This side will be smaller?
should be.
How do you know?
Because if you take a -5,
Uh-huh.
oh, I just did my math, so, yeah.
Is your math wrong?
My math was wrong at first, now it's, yeah.
So which side will be less, this side or that side? Anybody else can chime in as well. It's
Yeah.
not just Tyler's class. Which side will be smaller, the y side or the x side? The x side? The x side will be smaller? What are we putting in for x?
-5,
Okay, and what are we putting in for y?
8,
Okay. When we put -5 in for x, what will we get on this side?
9.
9. We know that because the point on the line is -5, 9. When we put points on the line into the equation, we get both sides are the same. Okay? But if we put this point in, if we put this x and this y in, they won't be equal. If you're going to get a point that makes the two sides equal, it needs to be on the line. But we pick the point below the line. Okay? So if we put a -5 in here, we get 9 on this side, and when we get on this side,
8,
we get 8 because we just put 8 in there, right? So which side is smaller? Which side is less?
the y side.
The y side is less. Okay? Where else, pay attention to this question, where else can I find points that when I put the x and the y in there, I get y values that are less than the side with x on it?
Would it have to be above the line? No.
We put above the line, let's say we did -5, 11. Well, when we put -5 in for x, what will we get?
9.
Obviously, we get 9 because that's the one that's on the line. -5, 9. That's the point of the line. So if we put -5 in here, we get 9, and on this side we get what?
11.
11 because we're making it be 11. So which side is greater?
The y side.
The y side. Okay. But I'm asking if I want to find more points where when I plug them into this statement here, the y side will be less than the side with the x on it. Where else can I find some points where that happens?
Anywhere below the line.
Anywhere below this point,
Yeah.
right? Will this point work? Will that y value be less than what you get when you put in that x? That x is just -5. We're going below -5 here. Okay. How about this one? Will the y value be less than when you put x into the right side?
Yep.
And here, and here, and here, and everything below, all those points, y will be less than the right side. Y will be less than the expression with x in it when you plug, for this specific example, when you plug -5 into it. Okay. How about here? This point is 1, -3. If I put 1 in for y, or x, sorry, 1 in for x and -3 in for y, what will happen to that equation?
They'll be equal.
They'll be equal. Isn't that what the points on the line, like the property of the points on the line, that's what they are, they have, right? Every point on the line, you plug it in for x and y, it'll make both sides of the equation true. Well, where can I find it here, right, around this point? Where can I find points that if I pick them and I put the x and the y in, I'll get the y side is less than the x side? Below it, right? Because this is the y value that you do get when you plug in 1. So if I want y values that are less than that, y being a vertical, up being bigger and down being smaller, then I would need to pick points that are below that point. -2, or -4, -5, -6, negative 6.5, negative 7 3/4. Anything below that where the y value is less than what you would get when you plug in that x value, right? And any point that I pick, if I plug in that x and that y, the two sides will be equal. But if I pick points that are below, will they be equal? Will both sides be equal when I plug these points in?
No,
No, what will be true?
the y will be bigger than the x.
The y will be bigger?
The x will be bigger than y.
The x side should be bigger than the y side, right?
Yeah.
Here we get, right, you plug in an x. When you plug in this x, right, you get this y. But if I pick y values or points that have y values that are smaller than this y value, then when I plug them in, the y side will be less.
Yeah.
Okay? So to show all of the points where that's always true, or if I plug in this x and this y, the y side will be less than the side of the x. How do I show that? How do I show all the values where when I plug it in, y is less than the side of x? Gavin? Shade. What?
Anything below the line.
Anything below the line. Because on the line, if I pick points on the line and I plug them in there, what happens?
It'll be equal.
They're both sides are equal. But if I pick points that are below, y being a vertical thing, right? Bigger y's up here and smaller y's down here. Then to show all the points where we have this inequality, they're not equal, right? When I plug in the x and the y, I don't want them equal. I want the y to be smaller than what you get when you plug in x. So if I plug in this x, I get this y. If I want y values that are less than that, I go below it. If I plug in this x, I get this y. If I want y values that are less, I need to go below that y value. So I've graphed the line, and the points on the line will make them equal, and the points below the line will make y less than the points on the line. So now, let's just color this in blue. And that becomes the inequality, y is less than negative 2x minus 1. So the negative 2x minus 1, if we wanted to show all the values that are where y is equal to that, we would just graph the line like we're used to. If we want to show all the values where y is less than that, we would shade below. So I'll put one to you. Number 15. So 15's got a couple of different things about it. Okay, so the first thing we're going to do is graph the line that this would make if it was 2x plus y equals 6. That's what the line represents. It represents all those places where both sides are equal. So how does that go? How do we do that? Did anybody graph this line? How did you do it?
Well, first I subtracted 2x to slope intercept.
Okay, so y is less than negative 2x plus 6. So if we thought of this as an equal sign, then we'd have slope-intercept form. So we can graph it that way. With the y-intercept of 6, the slope of negative 2, so down 2 into the right 1. And we can graph that line. The first thing, let's talk about this. Again, for the 100th time, and hopefully you're getting sick of it because you know the answer, not because you're sick of hearing the question and not knowing the answer. Okay. If I pick a point on this line, and I put in the x and I put in the y, then what's going to happen to these two sides? They'll be equal. Okay. Well, can they both be equal? Is that okay? Why is that not okay? You don't have that little or equals to thing. Well, but I could get really close to that line, right? Like, where would I shade in this instance? Anywhere below, right? Y needs to be less than the values on the line, so we'll shade below it. The y values are definitely less than the y values on that line. And so I can pick this point, or this point, this point, this point. I can pick this point right there, really, really close to the line. But once I get on the line, then both sides of the equation would be equal if I plug in that x and that y. And then, well, that would be okay, because one side needs to be less than the other side. So what can we change similar to this? Right? When x couldn't be equal to 5, it had to be less than 5. We left this circle open rather than closing it. So how can we show that we can get really close to a point on the line, but not quite on the line?
Dotted line?
A dotted line. Okay. So a dotted line still shows us,
Where it stops.
yeah, where the line is. It gives us that boundary,
Greater than or equal to.
but it also signifies that there's like an emptiness to this line. You can't have points on this line because it would make this inequality false. It would make both sides equal, and we can't have that. Yeah.
Was the dotted line's gonna make it greater than or equal to, or just
What's your question?
the y up there that it says that the y has to be is less than
This?
the y, and then the greater the greater sign, the one below it.
This one. This inequalities.
Yeah.
Okay,
Yeah.
yeah, I gotcha.
Wouldn't that make the greater sign greater than or equal to? Making it the dotted sign like that?
Making this line dotted?
Yeah, making that dotted, wouldn't that make it the y equal to? Greater than or equal to?
Well, first of all, it says y is less than.
I mean less than.
Less than.
Less than.
And not equal to, right?
Not
And the dotted line, let's go back again to this first page. The dotted line is like this open circle. Why do we make this circle open?
because you're not, because you're representing 0.
Not representing 0, no. We're at 5, we put an open circle, and then we shade everything to the left of 5. So why is the circle open as opposed to closed?
Because are you using 5, like 5 and below, and can you not be on 5?
Right, you cannot be on 5, right? You can't be on 5, x can't be 5,
Okay.
right? So that's why that circle is open. You can get really close to 5, and we want to highlight 5 so that you know there's a boundary there. But we want to show that you don't actually get to 5. You don't let x be 5, otherwise that wouldn't be true. And so the same thing for the dotted line. If we make the line dotted, then we're still showing you where the line is. We're still showing where the boundary is, where the shading stops.
But
We're also saying,
but you still can't be on the line.
right, we can't be on the line. Because, right, this is the 101st time. And I'm not saying that against anybody, I'm just saying, I say this over and over because it's really important. If you pick a point on the line,
makes it equal to.
it makes both sides equal. Okay. Good. Yeah, points on the line are a solution to that equation, but this isn't an equation, this is an inequality. We can do the same thing with any function now, right? As long as it's y and then stuff over here on the other side. Like y is greater than, y is less than. As long as we make sure if y is greater than, if y needs to be greater than the values on that graph, then we shade above that graph. And if it needs to be less than, we shade below that graph. Okay. So one type of function that we've been using is an inequality function. So we're to use like number 27. Y is greater than or equal to 2 times x minus 1. Minus 1. 2 times the absolute value of x minus 1. Well, y can be equal to this thing, and so what they have is the same graphs that we had been making in 2.7, an absolute value graph. We know it's going to be this V shape, but it's not going to be just the absolute value of x. It's not going to be this nice like 45-degree angle V. It's gonna be different. How's it gonna be different? It's gonna move places and it's going to like transform and become, the shape is gonna be a little bit different. So how do we graph that absolute value? The fact that nobody had any questions at the end of the quiz and all that kind of stuff should convey to me that we're all like, yeah, we can do this. So we should be doing it without any problem right now. So I'm assuming I have a lack of willing participants. Not-
Would you minus 2?
What's that?
Would you minus the 2?
Minus the 2. No.
Don't you multiply x with 1, I guess?
Multiply by 1. No, we're not going to multiply by 1.
So are we just graphing this?
Just graphing it.
Okay.
Not trying to
So
solve for anything. Yeah.
We make a vertex at 1, -4.
Good. 1, -4. Right there. Great. And now we have to draw the v part of it, right? But we have to know how steep it's going to be.
So 2 over 1.
2 over 1. So let's start here and go where?
Up 2 over 1.
Where's over?
Oh, positive.
To the right? Okay, up 2 and over 1. And we draw that guy right there. Is it okay that it's a solid line that I've drawn?
Yeah,
Because?
it's, greater than or equal to.
Or equal to, yeah, it can be equal to. Okay, well, it can be equal to, or y can be greater than the values of y on the graph, so where could we shade?
Above the line?
We can shade above the line, because all the values above the graph have y values that are bigger than the y values on the graph. So if we can get it down to y is greater than something or less than something, the shading part is it's a piece of cake. So now if I threw the graph of a line at you, or absolute value, or if we were doing a parabola, which we haven't done yet in this class, or whatever kind of graph, but I made it an inequality, you would just say, well, is y going to be less than the values on the graph, or is it going to be greater than, and you shade above it or below it? Okay. If you're thinking left or right, notice I have not said anything about left or right, because typically we're talking about y equals, or y is greater than, or y is less than, not x, right? X is horizontal. We could make it into left or right, but then we'd have to make x by itself, so we could be told what x needs to be, less than something or greater than something. So, since for convenience sake it's y that's by itself, we can go up or down. Above or below. Are there any questions from this section? Okay, I'm going to turn you over to your homework, so if you have questions you can ask me about that at that time.